Okay. So hello, welcome, and thank you for the warm introduction. I was Dev Talk also last year on the emerging tech stage, and at that time I presented 7 features which Bosch considers that will play a big role in Industry 4.0. I'm also happy for this year that Antonio did the previous presentation because in this case a lot of topics from Antonio's presentation related to the creation of value you will, let's say, find a little bit more palpable, but looking beside what is happening actually in a manufacturing plant. Because Industry 4.0 started, let's say, and was founded as a term in 2013, and this was an activity, a platform formed out by the German manufacturing big players. And why this happened? Because it was seen that bigger value also comes from higher investment in connectivity, in the Internet of Things, and trying to bring further this all the technologies and IT activities in the manufacturing area. If I would, let's say, speak about Romania and whatever the young guys knew about manufacturing plants and how do we consider that it's a life, the work and everything in a manufacturing plant, let's say we did not have the right view, or let's say we had a view coming from the latest 1980s and 1990s, where, let's say, in Romania the manufacturing was practically destroyed. But Industry 4.0 comes and wants to bring in as many technological new approaches as possible in the manufacturing area. And why? Because actually it's seen, and Antonio explained it very good before, that the value creation is moving. And the value creation is moving, and it's everything about connectivity and everything about sharing. There will be a lot of partnership between different players, but nevertheless, why I'm here and why I want to speak about Industry 4.0 in this case is because the company for which I work for, Bosch, is playing and will play a bigger role in this, because Bosch is a big supplier, one of the biggest suppliers for the mobility solutions, so for the automotive industry. And Bosch has, for example, almost 300 manufacturing plants worldwide with more than 400,000 employees worldwide working in research and development, but also in bringing high quality products in a mass production environment and bringing this at the right price level on the market. And for this, that's why the company has a dual strategy. The dual strategy refers to in being a supplier in the Industry 4.0, but being also a leading user in this Industry 4.0 topic. Furthermore, in short, I want to also explain why Industry 4.0 and which are the benefits from this approach. We've seen that Industry 4.0 mainly is considered the 4th industrial revolution, which were the first 3 industrial revolutions, and what kind of role did they play actually worldwide. If we have a look in the late 1990s or before, with the invention of the steam motor, with the invention of the production line, the introduction of the automation, we see actually a big increase in productivity. Actually, this big increase of productivity brings all the society further. You create, actually it's proven that you create more jobs, also with including automation, much more automation inside your factories. But increasing productivity, actually you also increase the way in which the market behaves. You bring affordable products inside the society, so the living standards are going higher and higher. But in short, to speak about a modern factory, we cannot speak only about the production line. Everything what happens in a modern factory has a lot to do with research and development, with logistics, with supply chains, with customers, and everything what you can put in a manufacturing plant. Actually, a manufacturing plant is a place where almost all the problems which you can get can intersect in that place, because you will find on the shop floor levels problems introduced by the research teams, for example, problems introduced by the logistic guys, but you will still have to deliver and achieve your targets. And in this case, applying more and more technology to the manufacturing plant is actually a must, and it's seen, for example, here, that a good linkage between all the logistic chain and the manufacturing plant will improve in the future the way in which we produce our products. Now I will switch to speak about concrete things. What means IT right now in this day in manufacturing? And I will speak about the Bosch Nexceed MES. And I will explain exactly what is a manufacturing system, and a manufacturing execution system. A manufacturing execution system is a system which nowadays is controlling all the manufacturing area. It can be considered as a big brother for production, or a backbone in the manufacturing. As an example, Bosch, as you know, has a manufacturing plant here near Cluj in Jucu, and in this moment, to run all the production in the plant, we have an infrastructure of over 250 servers. These are virtual machines which are running on a special cluster, on top of which the software solution is running. But more about the MES architecture and what it represents in a manufacturing plant. We all know, maybe you all also have seen on the discovery on how it's made, how goods are manufactured. Yeah, this level, let's say, it's the shop floor level or the manufacturing process. And you can see that this is a base. At that level, you actually control temperatures, pressures, you control movements which are done at that level in order to assemble your products. But everything goes, for example, in the chain of having everything in an ERP software. At the enterprise resource planning, of course, you have the data from the research, so you have the drawings, you have all the financial data, the human data, and so on. And it's seen that you need a higher level of connectivity between these two systems or architecture levels. And in this case, the MES plays the role of managing whatever it's defined at the enterprise resource planning and bring it at the shop floor manufacturing level. So actually MAS is a place where order allocation is done, where backtrace it's performed. For example, in Cluj right now we store for the traceability more than 35 gigabytes of data per day. And I'm not speaking about data like photos and so on. I'm speaking, yes, for producing this part, I had to screw it with these parameters, 20 kilonewtons, this is the torque force, and so on. And this is the level in which the MAS it's doing the traceability. Of course, you can do also the quality management system via the MAS. More example will a nice example related to the quality management is the possibility to do statistic process control. The possibility to control, for example, in a manufacturing plant which assembles ECUs, so electronic control units, which assembles those little SMDs on the boards. There is the possibility, for example, to safeguard their moisture sensitiveness. Every little device has a moisture sensitiveness level. And for example, in the manufacturing area, this is a problematic topic because when you put that device on the machine and you want to assemble it on a board, you have, for example, only 12 hours in order to consume that material. If you do not consume that material in 12 hours, for example, you can scrap it, throw it away, and then you will lose money. And in order to safeguard all of these rules, MAS here plays a very big role in tracing this and blocking the manufacturing line, and blocking the material on the material management system, and so on. And furthermore, because we speak about MAS and the increase of connectivity in production, this is an extra architecture, but it's defining only the MAS system. What does this mean? At this level, we have the shop floor. We have the logistic part with the receiving area where all the goods in a manufacturing plant are received. Then we have part of manufacturing, then a pre-assembly, a final assembly, an inspection, and a delivery place. Between them, you can see extra quality gates. Quality gates which could be processes which will safeguard your quality of the product, but they can be also routines implemented inside the MAS system which will safeguard your product related to interpretations of data which were acquired before. All of the line with all of the automation you need, it will be connected to a machine interface with which these machines will communicate. What does this mean? That every time when a part is produced, this has to be uniquely identifiable. So every part that a manufacturing plant is producing has a unique identifier, which of course is generated inside the MAS system and it's engraved on the part. Then it has an identity inside the system. In an automatic manufacturing mode, a machine will, when the part arrives at the machine to be processed, the machine will inform the MAS system that that part has arrived. This information goes via a machine interface, And then based on the specification and what kind of data do you want to aggregate, consume at that level, this machine interface will transfer the data to all the other modules in order to be processed. Here we can see that we have maybe administration modules, we have production data or manufacturing data modules, maintenance, quality, traceability, and so on. And then rapid answer will be transferred back to the machine, and the machine will be informed, yes, you are allowed to process this part, please process it with these parameters. Or, for example, no, you are not allowed to process this part, you have to perform a changeover, you have to change the material which is mounted on you, you will have to change the tools with which you are set it up, and then the machine will inform or will perform automatic changeovers or inform the personnel in charge on the line. Furthermore, on this furthermore, on the chain of communication, there will be at the end of processing the part an information of the manufacturing machine related to all the production parameters which were used and which were acquired during the manufacturing process. These parameters will be stored and furthermore will be used in order to, for example, create a label, in order to write down a software, because right now all the parts which we produce have at least a small part of software inside them. And in this case, as I stated before, currently, for example, in Cluj, we acquire 35 gigabytes of data every day. Much more over to think about some extra numbers. These numbers, let's say, will be quite, from my point of view, amazing. Every day, for example, in an ECU manufacturing plant, we use more than 25 million parts. And these 25 million parts are used to be assembled in final products. Okay, some extra more numbers related to the MAS system, because yeah, it's quite interesting. When we speak about the communication between the machine and the MAS system, we speak about also a high level of performance of the response time of the system. As I said it before, for example, we have a cluster of with many servers. We have to produce, but we know that in a manufacturing plant, everything is focused on productivity, on cycle time. We cannot affect the cycle time of the line, because this will increase the cost of the line. So in this case, the response times of for every request are between 5 milliseconds and 200 milliseconds. So you need a high performance level, and you need a high IT performance environment in this case. Related to the MAS topic, I can state if you have implemented this on every machine, you acquire a high level of connectivity. So you have a huge amount of data which can be used anymore, and you can additionally go and perform and think to do other tasks. One of these tasks will be, hopefully we will also have the possibility to show up a slide, and I will speak about a smart replenishment service. A smart replenishment service, it's offering the manufacturer the possibility to move manual work or manual input data into the system, also manual orders, to move them in the IT environment and perform them automatically. Having a machine connected in this way to an IT system, it gives you the possibility to know exactly which in real time, which are the consumptions which you performed related to the material to be assembled on the line. And this giving you the opportunity to aggregate, for example, data from the ERP system where you have the orders coming from your customers. Then you know exactly what kind of goods you have in the warehouse. You know exactly which is your production plan. And then you can aggregate all of this data in order that a routine is created, and from the shop floor level, automatically an order will be placed in the warehouse for doing the automatic replenishment of the machine. And then having in real time delivered on the line the material to be assembled. This offers a quite huge advantage also from the perspective that if you think from the financial point of view, when you assemble millions of products, millions of micro parts every day, you will have also to keep the track on them, to know exactly where you use them and how can you move the stocks from one area to another. So an MES system is also responsible for triggering the ERP systems in order to move these stocks. So a part is being produced on the line. When the part is finished on the line, an automatic trigger is performed. So in order that in the ERP system, that becomes a part which is sellable. And being sellable immediately after you manufactured it, this means a lot for a manufacturing plant in order to have this transparency. Okay. Having this level of connectivity also gives us the chance to go further. I spoke about a smart replenishment service. I spoke about automatic stock detection and movements in the ERP systems. But these are all happening in the backgrounds, behind the system. What else can we do with all of this connectivity? Thinking of the previous example, right now we knew that, we can know exactly when a material can be shipped or has to be shipped on the line. Knowing this and knowing exactly the locations of the stocks will allow us to really perform an autonomous delivery of the goods in production. And about this topic I will discuss in this moment. It's a system which is already, for example, implemented in Cluj. It's the autonomous delivery of the goods in the production area via AGVs. I wanted to show it to you more exactly, to see exactly a graphic on how this is performed, but hopefully we can show it maybe a little bit later. The automatic delivery with the AGVs, it's realized and contains at the end of the implementation 3 big more solutions behind. One, of course, is this high level of connectivity. The other one is the level of MES and data aggregation, where you can all process all of this data. And another part is in the logistic area, and it's related to an intralogistic solution set. So the intralogistic is related to the internal transportation system in a manufacturing area. And having this level of connectivity, it's allowing you to know exactly where do you have to ship your material, and in that case you can automatically allocate orders and push orders in from the manufacturing zone to the logistic area, and then watch the delivery of the goods in production. Okay. Maybe we can take also time out. Sorry for these technical problems. But if you have questions, I don't know, is any one of you having a link beside my Bosch colleagues which are here, a link with providing solution in the manufacturing area here? Has anyone of you seen a manufacturing plant? Okay. Okay. And how was it for you to be in a manufacturing plant?
Sorry. So, from my point of view, as you have presented so far with this solution, IoT solution for manufacturing plants, my question for me was, I think that this solution can also provide a more agile production lines, as it can provide a real-time, let's say, heat map of the entire factory, not related only to the product life cycle, but also to how we manufacture them, or how do we place the lines maybe in a factory. And this system can even reduce waste, not only waste of time, but also waste of transport. As you said, you have the HEV vehicles that can help you replenish the lines. Maybe with this, we can continuously improve. I think this is...
Yeah, this is lean.
Yeah.
Yeah. Okay. I want to also make a proposal for those of you who have never been in a manufacturing plant. During next Sunday, there is includes the Bosch Mobility Day, and there will be organized also visits from the city center, from the engineer center, to the Bosch factory, and there we will also show this new technologies introduced in the manufacturing area. So if you want, on Sunday there is a Bosch Mobility Day. You can find it on Facebook, and then you can also come and see a modern smart factory. Yeah. Another approach, and here is also Cora Kaszek, which we also discussed a lot, is that right now the technology and the aim of manufacturing is to cope and to have the production flow strictly linked to the information flow. And everywhere and every time when data needs to be consumed, it has to be available there at the right time, in the right moment, in order to take a decision. I'm also working in IT. In IT, you have a lot of also buzzwords, but being also involved in the manufacturing and working a lot in manufacturing, I can say that manufacturing is very, very agile. It's very agile. Actually, you have to really do it in the right way. Of course, there are a lot of standards, but you have also to take a lot of decision in the right time, in the right moment, having the right data, also aggregated, also present in every time when you need it. Okay, we see that the technical problems did not finish. I also had a movie for you to show you. the AGVs. We have a question, yeah, okay. That's great.
Okay. So can you talk a bit on the technologies used to handle so large data?
Okay, good that you ask. So there are not, let's say, of course, from the investment perspective, it's quite high. Yeah. So we speak about several hundreds or millions of euros, actually. Yeah. But you try to keep and to bring the performance very high. So you have an Oracle Metro cluster. You have special hardware where you run your virtual machines. You have special SSD storage. For example, 1 year ago, we just invested in the SSD storage where all of these applications are running, and of course, we are also storing data. We invested only in storage around 1 million euros, and this is quite a big amount. Yeah. Then you speak about all of these applications. In the moment they are running on Linux or Windows Server. Then you use the you speak also about the infrastructure. Network infrastructure is very important, but you cannot go, for example, at the automation level, which we spoke about. You can, in general, you will go with deterministic protocols like Profinet, Profibus, and so on. These are very good in knowing exactly and making the let's say, the security of transferring in time the information from one place to another. But the extra environment which is running on server side is not really deterministic. And then you have to really develop these applications and to find out the right architecture and right setup in order to have this kind of system. So these kind of systems are distributed. The architecture can be increased, and let's say straight, you have to invest quite a lot also in hardware. Okay.
Yeah, perhaps to bridge the technical break situation. In such a manufacturing plant, there's a lot of standards, otherwise you cannot handle it. Yeah. And MES, this is one system that Radu has introduced, is one of the basic standards to get the data out of the different machines. And this system is preparing and filtering and organizing data that then will be sent to so-called big data storages, where then with the related investigation methods, the data are just interpreted from the quality viewpoint, from the delivery viewpoint, and so on. And this is a very, very huge effort. So Radu, you can perhaps also tell something about the standards that we are using there. It's very important is that this is a real-time environment, and the answering times have to be very, very fast. So we cannot just wait for a system that is not really working and have an influence on the production sequence or the takt time of the manufacturing areas. So the main programming tools that we are using is .NET, Oracle databases. So we have special environments that assure the real-time activity, and we are also using, let's say, higher generation tools that are just used to interpret these data. But I hand over to Radu, then Radu, you can really explain a little bit what is necessary. One thing is very important in a manufacturing plant, so we cannot live with blue screen stuff or so. Yeah? So the things has to really function. And I just can give you an example what happened when something goes wrong. We had, in a robot system, we had a breakdown. It was a quite complicated machine that is using two robots to crimp a housing for a product. And we needed 3 days to completely disassemble the system, to find out that it was a very small screw that was broken in the system. And during this time, of course, we normally had to deliver thousands and thousands of ECUs. So we were just getting in a very big delay and having then to recover from this area. So manufacturing environment is real life, and there Internet of Things or smart everything is a real challenge, because you also have history. You have new machines, you have old machines, you have machines that are easy to interface, and you have other systems that are very difficult to interface. So for this reason, the Industry 4.0 and any kind of industrial automation is one of the, let's say, most realistic and biggest challenges in ramping up the Internet of Things. It's just something completely different than just flying a drone automatically or something like that. So, yeah, but you just explain a little bit from your daily life to just bridge until we can continue with the media.
Okay, so but also to complete the answer to your question, what do we use to process all of this huge amount of data? We spoke about standard Oracle database, of course, on special hardware base and environment, but we speak also about an analytics cluster. So a plant right now needs an analytic cluster, and we have a Hadoop environment in the plant, which helps us in order to process that huge amount of data. And on top, of course, you put data mining solutions or data and process the data streams with Spark, and then bring the data at the level where you can show it up with data mining view tools like Tableau, SPSS, and so on. Yeah, so there is a wide variety of technologies and approaches in this case. Okay, I see that still technical topics. So IT is still a topic here, and yeah, do you have extra questions?
Hi, thank you very much for the information. I think Bosch here in Cluj, you do a lot of electronic control units and a lot of different parts. Regarding big data and everything you mentioned, all the systems, is it very specific to Cluj, or is this more of a Bosch strategy? So does it match with other Bosch plants as well, or is it very much a Cluj strategy?
It's Bosch worldwide. So in general, as I said at the beginning, Bosch wants to be a name, and it's investing a lot in starting from several years in these technologies, and actually bringing the know-how of the company, because we know that the Germans produce good quality products, mass production products, and then this know-how of manufacturing, yeah, and being a user of certain solutions is transferred in the area where Bosch, let's say in the name of with the subsidiaries like Bosch Rexroth, Bosch Connected Industry, is also playing the role of a supplier. So this approach is happening worldwide, and I think Mr. Kaszek wants to say something.
Yeah, so as I explained, standardization is very important. And to be really able to interface the systems, you have to create some kind of very disciplined setup. Yeah. For example, understanding this, we have implemented a company-wide data management organization that is just defining data structures and shaping the data world. Because if you don't do this, you will not be able to create anything networked. You see that even such kind of a very simple media connection can sometimes bring a lot of challenges to the organization. And imagine a future world of Internet of Things, of systems that are necessary to run an automatic driving car and so on. So the discipline and a very straightforward approach to define your data environment is the first step. Then you need to standardize the tools. Yeah? There are several providers of the tools, several providers of sensors that you can use. I see we can just get forward. But standardization is very important. Standardize the programming tools. Don't expect too much from artificial intelligence now. It is a real hype currently, but as I explained during my introduction, there are two ways of artificial intelligence. Let's say the soft way of artificial intelligence, that is just using algorithmic technologies with knowledge-based work to create added value from the IT point of view. And there is something that a lot of people are just hoping about. This is a strong artificial intelligence which is human-like, or which is assumed to be human-like, cannot be identified as machine anymore. Once again, discipline. Every programmer knows it. Discipline is very important, and also it is very important to have the right approach to make generation changes in the tools that we are using and so on. Okay, so I think the systems are working once again. And then
I think we still have 2-3 minutes to finish.
Yes.
Yeah. Yeah, at the end, I will just want to, let's say, related to the smart replenishment via MES and automatic ordering, placement, and AGV. I just want to fast go through my last slides and really show you a movie from our factory, where you are also invited on Sunday if you want. Okay, just a short refresh, because we have to finish. We were speaking about a smart replenishment system where you have a production plan. Of course, then you can generate a material demand directly on the line. In that moment, the material demand will be purged and transferred to the other system, also ERP systems, and then you can create a route based on the locations of the material in your factory. In this case, you create a route, and then you can automatically assign a job to AGV. And right now, I will show you a short movie from Cluj. This is a project which we implemented last year. This is a small IGV. We call it Kate. And Kate is delivering SMD components to the SMT line. So from the warehouse, these systems right now are providing all the information needed so that when the material is already prepared, of course, ordered and already prepared in the logistic area, there will be an automatic pick of the transfer order, and this will be moved directly to the line. In this case, you can see those are SMT reels, so small components to be placed on the PCBs. And yeah, Kate is making the delivery, taking back empty box and bringing it to the logistic area. Okay then, this was my presentation from today. Thank you very much.